Hello friends, welcome you all in this video lecture of B.Sc Electronics. Myself G.G. Patil, Department of Electronic Science, KTHM College, Nasik. In this lecture, we have to study merger graph method of state reduction. So let us start. First of all, we will see what is the merger graph and how it is used for reducing the number of states so that a simplified sequential state machine can be derived. In the earlier lectures, we have studied the state equivalence method of state reduction, then the implication chart method of state reduction. Now, this is the third method of reducing the number of state in which we have to use the merger graph. First, we'll see what is the merger graph. The merger graph In the merger graph, the number of vertices is equal to number of states in the state table. Each vertex correspond to a state in state table. Merger graph is again the graphical method in which we draw the number of vertices which are equal to number of states given in the state table, and this method, merger graph method, is the state reduction method of incompletely specified state table. Now, what is incompletely specified state table? We'll see next. Here, the each compatible state pair is indicated by a line drawn between the two states. Means if the two states are compatible states, then we just connect those two states by the solid line, and each potentially compatible state pair with outputs are same but whose next states are different is connected by broken line that we will see in the diagram. The implied states are written in the line break between two potentially compatible states. If two states are incompatible, then no connecting line is drawn. So, from that, we come to know that these states are not compatible. So, we shall see the example of merger graph and how to draw the merger graph for given incompletely specified state table. So, we know the incompletely specified state table. This is the example of incompletely specified state table where A, B, C, D, E are the states and their next states are given here, and their outputs are also written after the slash in the state table. So, if some of the outputs are missing in the state table, then such a state table or a state machine is said to be incompletely specified state table, which is given in this table, and we have to use merger graph method for this state table to find the compatible state pair. In case of merger graph, instead of saying equivalent state, we call the states as a compatible states. So that thing must be noticed by the student. Now see here, the in the present state there are five states are listed A, B, C, D, E, and as stated in earlier slide that number of states equals to number of vertices. So we have drawn of five vertices A, B, C, D, and E. That is what the number of states equals to number of vertices. So in the present state column, the number of states are listed. Those number of vertices are to be plotted on the paper. So here the five vertices are taken and the line between the states is drawn if they are compatible. So from the state table we have to draw these lines, and where the states are not directly compatible, they are potentially compatible, then those two states are connected by this broken line, and in between the line break that potentially compatible state pair is to be written just like here. The BC state pair is written means A and E is compatible by this potentially compatible state pair, and similarly for rest of the cases where the outputs are not same, they are different, the line is not drawn between those two vertices. Here, these 2 points are open means these two lines are incompatible with each other, so they are not connected by the line. We'll see one by one, point by point. Now, see here in the present state column, we first uh, take the state A and state B. First of all, what we have to take care, we have to take care of outputs. Where outputs are different, we have to keep it open, we have to keep those states open, that is no line has to be drawn between those states. So see here, the output is 0 unspecified, so we can specify it as 0 unspecified, 0 0 0 and unspecified and 1. So these two states can be compatible, and the states by which it may be compatible is AB itself. So AB is compatible to AB, that is each state is compatible or equivalent to itself by the equivalent state properties. So AB is compatible and therefore a line is drawn between the state AB. Okay, then check the AC state. Now see the output first. Here is 0 0 unspecified 1, so we can specify 1 there. 0 unspecified, we can specify 0, and unspecified we can take it as either 1 or 0. So AC can be compatible and can be compatible by the potentially compatible state pair CD. Here nothing. So AC is compatible by CD. So the line is to be drawn between point A and C, and it will be the broken line because in the line break we have to write that potentially compatible state pair, which is CD. Here that state pair is written between point A and C. So we can call as A is compatible to C by potentially compatible state pair CD, that is C is compatible to D. Then check the next pair A and D. Check the output first. 0 0 unspecified 1, so it can be specified as 1, so they can be equal. 0 0 and unspecified, so A can be compatible to D by which state pair? C. It is the same state. Unspecified AE, so only one pair is there, AE. So AD is compatible by potentially compatible state pair is AE. AD is compatible by AE, so it is written in the line break A pair. Then check the AE. Check the output first. 0 0 same, unspecified can be same, 0 0 same, and unspecified and 1. So outputs can be same, they are not in conflict value. So check the potentially compatible state pair for AE. Here is CB, or we can say BC, then AA, and nothing is here, so it can be compatible by BC. AE is compatible with potentially compatible state pair BC, so it is written there. Now check rest of the state pairs. Now B and C, check B and C. First output unspecified 0 0 1, so here output is 0 and here is 1, so it is different, it is not equal, so B and C cannot be compatible, so no line is to be drawn between point B and C, means they are incompatible. Now check the next pair B and D. Check the output. Unspecified 0 can be same. Again 0 and 1. Output is different, so no need to proceed there. Just remain it unconnected. B and D. B and D. No connecting line is drawn, means it is incompatible. Then BE, check the output, unspecified 0, 0 unspecified, 0 0 same, 1 1 same. So B and E can be compatible and can be compatible with potentially compatible state pair. Here nothing, state is not specified, here state is not specified. B and A means AB and here DE. So B and E is compatible by two potentially compatible state pair AB or BA and E and D. So BE, see here, BE is compatible with two pairs potentially compatible state pair AB and DE. Then check the next states starting with C. C and D. Check the output 0 0 1 1 unspecified 0 unspecified unspecified. So outputs can be same. Then check the potentially compatible pair CD AB. So CD is compatible with these two state pairs. CD is compatible with two state pair AB and CD itself. So there is no need to write CD again. So it is compatible by pair AB. Then check next pair CE. Check the output 0 0 1 not specified, not specified 0, not specified 1. So C and D can be C and E can be compatible with the compatible state pair BD. Yes, BD. CE is compatible with BE, BD. So this BD pair is written in the connecting line between C and E, and the last pair DE, see here output 0 0 1 unspecified 0 0 unspecified 1. So D and E can be compatible with compatible state pairs BC and AE. So in between D and E, two pairs are there, BC and AE. So in this way, from the incompletely specified state table, we can draw the merger graph for given incompletely specified state machine in this way. Once the merger graph is drawn, the next thing is we have to check the compatibility of these implied compatible state pair. Means what? Where the two states are connected by a broken line and in between the line break those implied state pairs are written. So we have to check the compatibility of those state pairs. So first we'll see starting with AB, then AB is compatible, then AE, AC like that. So we'll see the AC next. Now the explanation is written here. The state A and B are compatible since no compatibility conflict exists that we have seen. AB is compatible. State pair AC is implied compatible by state pair CD. AC is implied compatible by state pair CD. Then state pair AD is implied compatible if AE is compatible. State pair AE is implied compatible by BC, and state pair BC and BD are not compatible. BC and BD are not compatible because outputs are different. States B is compatible to E if E is compatible to D, if implied compatible state pair AB and DE are also compatible. That is what we have taken in the earlier slide, the explanation we have seen. Similarly, for rest of the cases, now we'll see the compatibility. We'll check the compatibility. Now see A and E. The cross is cross mark is placed because BC is incompatible. See here, BC is not connected by line, means it is incompatible. So wherever BC pair is present, those states cannot be compatible. So AE is crossed. Similarly here, this will be get crossed. So next pair to be crossed is this one. ED will get crossed. Now for next of the cases, the next BD will get crossed. Why BD? Because BD is also not compatible. So B and D state pair is present in the place that those states will get crossed. Those states cannot be compatible. So these states cannot be compatible. The next is this state pair get crossed because AB, see here, AB is present and AB is compatible, but another state pair DE is present and DE has got cross mark placed there. So D, this with the presence of D, that EB will get crossed. Now, is there anything getting crossed? Yes, AE, because A is crossed here, so AE will also be getting crossed. Now, what is left uncrossed? AC, CD. Okay. Okay. So AC is compatible by state pair CD, and check the CD. CD is compatible with AB, and AB is compatible. So AB state will be compatible, AC state will be compatible, and CD state will be compatible. They cannot get crossed. So in this way we get the compatibility of state table. We get the compatible state pair from the merger graph. It is a very simple method or very simple technique to find the compatible states from incompletely specified state table. So here the explanation is given here. Therefore, the state pairs AB, AC, and CD are compatible. They are left uncrossed, so it is compatible. Now, the next thing is the minimal set of compatibles and maximum compatibility. So, let us see first the minimal set of compatibles. The set of compatible state pairs, as we got in the last slide, that produces the smallest reduced state table is called the minimal set of compatibles. What is minimal set of compatibles? It is a set of compatible state pairs that produces smallest reduced state table. That is called the minimal set of compatibles. And the necessary condition to find the minimal set of compatible is to find the maximal compatibles. Now, what is the concept of maximal compatible? Most of the time, this minimal set of compatibles and maximal set of compatibles, they are asked in examination. The definition of these two terms, minimal set and maximal compatibles. So, student must note this thing. The maximal compatibility. What is meant by the maximal compatibility? A set of compatible state pairs is said to be maximal if it is not completely covered by any other set of compatible state pair. So that is what the maximal compatible set of state pairs. A single state example is given. A single state that is not compatible with any other state has maximal compatibility. Any single state not compatible to any other state is said to be a maximal compatible. A set of compatible state pairs in above example are not maximal. In the last slide, whatever we have obtained, These are the compatible state pairs A, B, AC and CD. They are not maximal compatible because some states are missing there. The partition the states. Now to get the maximal compatibility, how they are to be obtained? So they are to be obtained by partitioning the states into as few groups as possible where all the states in a group are compatible with one another. The states in the group are compatible with one another. So we'll see this in the next slide. The maximal compatibles can be found by constructing compatibility class graph. This is important. Now, what is the compatibility class graph? It is used to find the maximal compatibilities. It is given in the next slide. See here in the last uh, earlier slide, we in the example of merger graph, we have found AB is compatible, AC is compatible, and CD is compatible, while state E is not compatible with any other state pair, so it is shown different separately. So in this way, we can group the states as stated earlier. AB is compatible, it is grouped in the one, it is grouped together. Then CD is compatible, it is again grouped together, and AC is also compatible, but since A is covered in this group and C is covered in this group, there is no need to take it again. So in this way, we have to form as few groups as possible where all states are compatible with each other in compatibility class graph. This is the compatibility class graph, for example taken in merger graph. How to draw it? The AB was compatible, CD was compatible, E is kept separately because it was not compatible with any other state, and AC was also compatible, but they cannot be grouped because A and C are covered in separate group, so there is no need to group them together. Okay, that is what given here. Compatibility class graph has vertices and connecting lines like a merger graph. It is exactly like the merger graph, number of vertices and the connecting lines. The connecting lines are drawn between the states which are compatible, which are found to be compatible. It shows only compatible states. Only compatible states are shown. In the merger graph method, the compatible states obtained are AB, AC, and CD, while state E is not compatible with any state. Therefore, its compatibility class graph is as follows. It is given here. The maximal compatibles are obtained from compatibility class graph by identifying the largest group of connected compatible state pairs. By that way, the maximal compatibles are obtained. Here, in this example, maximal compatibles of A, B, C, D, and E exist. These groups are formed. AB is under one group, CD state in another group, and E is not compatible. It is taken separately. And next task is to what? Is to find the closed set of compatibles which must cover all the states. But it contains compatibles, implied compatibles, and all original states. So in this example, we'll get the maximal compatibles AB, two states are covered, CD, another two states are covered, and E, which is separate E. So sorry, all the states are covered in this group, so it is the closed set of compatible. So in this way, we can find the compatibility class graph. Sorry, in the for the given state table. Once it is done, they are to be renamed like this. They are to be assigned the new values here. Assigned the group AB has assigned S0, CD has assigned the new state value S1, and E has assigned a new state value S2. By assigning these two values, assigning these new values, we can find the simplified state table as given here. This is our original state table, incompletely specified state table, and By assigning these values, first we find the compatible states in that state table, and we have assigned the new values, and we can get the simplified state table drawn here. Wherever AB state is there, we have to assign value S0. For C and D, we have to assign S1, and for state E, we have to assign S2. And the unspecified output has to be kept unspecified. So see here, in case of AB, we will assign S0, S0. C is there, we will assign S1. Then E is there, E has to assign S2. AB, AB are in common group, so S0 will be there, and here D is there, S1 will be there. And what output is to be taken? Here 1 is, see here, S1 0, here 0 is specified, so we'll take 0. 0 is specified, so we'll take 0. Here 0 and here 1, so we'll take 1. Then for CD we have to assign S1, then take the CD. For CD SG or CD state S1 is to be assigned, and output will be 0. Here AB, for AB S0 has to be assigned, and output will be 1. For state E S2 is to be assigned, and output is 0. And here nothing is specified in next state and output, so keep it as it is. And the last is E. State B is there. For B we have to write S0, and output is 0, S0 0. Nothing is specified, so keep it as it is. A means S0 0, and E S2 1. So in this way we can draw the simplified or reduced state table or given incompletely specified state machine or state table. So to summarize, in the merger graph we draw the number of vertices equals to number of states given in the state table. We draw the connecting line between the vertices if they are compatible. We draw the broken line between the vertices if they are potentially compatible states, and in the line break we write the potential compatible state pairs by which they are compatible. Once it is done for the whole states, the next thing is to find the compatibility, or is to check the compatibility of implied or potentially compatible state pairs. Those which are incompatible are to be crossed, and after crossing all those possible states which are remaining uncrossed, they are said to be compatible. So in that way we find the compatible state pairs in the uh, using the merger graph. Once it is done, we have to find the maximal compatibles, minimal set of compatibles. To find the minimal set of compatibles, we must know the maximal set of compatibles. Once we got the maximal set of compatibles, uh, then draw the compatibility class graph, and from the compatibility class graph we get the possible groups of the state pairs. They are to be reassigned the new state and draw the simplified state table. So in this way the merger graph technique is there to find the compatibility of the states in the given incompletely specified state table. Thank you.